Good morning, children. I hope that everyone is fine and staying home safe and healthy. This pandemic has brought about a great change in everyone's life, which we never expected of. But we all have accepted this challenge, and the new system of online teaching has helped the students to become more of self learners and understand their self strength. I've seen that some of the students have done really good, and I hope that in the near future, all the students are with their textbooks and they're doing their work sincerely and showing their best in the truest sense. Thank you, children.
Hello students, hope you all are good and not wasting this crucial time and studying hard to achieve good marks in your board exams. Today I'll teach you lesson number 4 of your book. The name of the lesson is Refraction of Light at Plane Surfaces. Children, in your previous class you've already studied about reflection. The return of light in the same medium after striking a polished surface is called as reflection of light. And the reflection of light ray obeys two laws. The first law is that the angle of incidence is always equal to the angle of reflection. And the second law is that the incident ray, the normal at the point of incidence, and the reflected ray all lie in one plane. Now in this chapter, we will study the refraction of light through the plane and spherical surfaces of transparent media. Now talking about the speed of light. The speed of light is 3 into 10 to the power 8 meter per second in vacuum or air, and this is the maximum speed of light. Now when light enters any other media, its speed changes. The speed of light becomes 2.25 into 10 to the power 8 meter per second in water, and the speed of light is 2 into 10 to the power 8 meter per second in glass. Thus the speed of light is maximum in air, and then in water, and then in glass. Thus the speed of light remains constant in a transparent homogeneous medium. But when light enters from one medium to the other medium, so it either slows down or it speeds up depending on the optical density of the medium. Now talking about the optical density. While passing from one medium to the other, if light slows down, the second medium is said to be optically denser than the first medium. And if light speeds up, the second medium is said to be optically rarer than the first medium. Thus, water and glass are optically denser than air. Or we can say air is optically rarer than water and glass. Similarly, glass is optically denser than water, or water is optically rarer than glass. Now, refraction of light. In a transparent homogeneous medium, light travels in a straight line path. But when a ray of light traveling in one transparent medium strikes obliquely at the surface of another transparent medium, a part of light goes back into the same medium, obeying the laws of reflection, and it is called the reflected ray. The remaining part of light enters the other medium and travels in a straight path different from its initial direction, and it is called the refracted light. Thus, this is the incident ray, this is the reflected ray, and this is the refracted ray. The angle made by the incident ray with the normal is called the angle of incidence I. This is the angle of reflection. And you know the first law of reflection, that angle of incidence is always equal to the angle of reflection. So these two angles are equal. And the angle made by the refracted ray with the normal is called the angle of refraction, which is represented by the letter small r. In this figure, SS dash is the surface separating the two media, say air and glass. When light traveling in one medium falls on the surface SS dash, a small part of it is reflected back in the same medium, obeying the laws of reflection, and the rest of it is refracted through the other medium. That is, there is partial reflection and partial refraction at the boundary surface. Thus, what is the definition of refraction of light? The change in the direction of the path of light when it passes from one transparent medium to another transparent medium is called refraction. And refraction of light is essentially a surface phenomena. Now, it has been observed that there is a difference when light passes from one medium to other medium according to the optical density. When a ray of light travels from rarer medium to denser medium, say from air to glass, like this diagram, it bends towards the normal. See here, this is the incident ray and this is the refracted ray. When light is passing from rarer to denser medium, it bends towards the normal. And this diagram shows that when the light ray passes from denser to rarer, suppose the light is passing from glass to air, then it bends away from the normal. In this case, angle of refraction is less than the angle of incidence, and in this case the angle of refraction is more than the angle of incidence. Now, when the ray of light is incident normally on the surface separating the two media, it passes undeviated. That is, such a ray suffers no bending at the surface. Thus, if angle of incidence is 0, then the angle of refraction is also 0 degree. The deviation of the ray is 0 degree. It passes straight. Now, the next topic is cause of refraction or the cause of change in direction. When a ray of light passes from one medium to another medium, its direction or path changes because of the change in speed of light in going from one medium to another. As I've already told you, when light ray passes from one medium to another medium, its speed changes. Thus, its path also changes. In passing from one medium to other, if the light slows down, it bends towards the normal, and if the light speeds up, it bends away from the normal. And if the speed of light remains same in passing from one medium to another, the ray of light does not bend. It passes undeviated. Now, laws of refraction of light. First law says that the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. That means the incident, the refracted and the normal at the point of incidence, they will lie on the same plane, whether it is the plane of paper or the plane of any table or the plane of wall, etc. And the second law says that the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for the given pair of media. That is, sine I upon sine R equals to constant, which is called refractive index, and it is represented by the letter mu. It is called as refractive index. The sine I upon sine R equals to mu to 1. That means refractive index of second medium with respect to the first medium. Now, next I will tell you effect on speed, wavelength and frequency due to refraction of light. When a ray of light gets refracted from a rarer to a denser medium, the speed of light decreases, while if it is refracted from a denser to a rarer medium, the speed of light increases. Thus, the speed of light changes when it passes from one transparent medium to the other transparent medium. But the frequency of light depends on the source of light. So it does not change on refraction. And since the wavelength is related to the speed of light by this formula, we know V equals to F lambda. That means lambda, that is the wavelength, is equal to V upon F, velocity upon frequency. Thus the wavelength depends on the speed of light. If the speed of light will decrease, the wavelength will also decrease. And if the speed of light will increase, the wavelength will also increase. Thus, when light passes from a rarer to denser medium, the wavelength decreases. And when light passes from denser to a rarer medium, the wavelength increases. But the frequency never changes. It remains unchanged. Speed changes, wavelength changes, but frequency does not change. Now, refractive index. We have already studied the second law of refraction of light, which states that the sin I upon sin R is a constant, which is called the refractive index. Thus, the refractive index of second medium with respect to the first medium is defined as the ratio of the sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium. And talking about the unit of refractive index, as you see, it is the ratio of two similar quantities. Therefore, refractive index has no unit. Thus children, this is all for today. Thank you so much.